Beginning with, let us first understand what exactly is cloud computing. So I am expecting the participants from uh, various years of engineering, and I'll be taking this session. So first of all, what exactly is cloud computing? When I try to speak with some people who are as a beginners, who are about to start learning cloud computing, people always think cloud computing as some source of computing where we can store huge amounts of data. But to make it clear, cloud computing is in simple computing on internet. When I say computing on internet, what does computing consist of? Computing consists of asset storage, computing consists of processing power, computing consists of IO input, output, etc. It also consists of networks. So whatever the resources that comprises of computing is completely moved onto the internet and is available for access through internet, and in simple we call it as the cloud computing. So the question is, why do we require internet? The answer is very simple. The cloud computing resources are not available in our premises, but are actually available at some remote location. So the resources are available at some remote unknown location, geolocation, and we are able to going to access those resources through internet. So internet is actually our communication media. Then again the question comes is, why do we require a network? Why do we require a communication channel other than internet? The answer is very simple. The computing resources, the cloud computing resources are again not available at a single geolocation, but are again geographically distributed. And they're all interconnected together by using some communication media. So now, as a user of cloud computing, we connect to the computing through internet. And whenever we are trying to connect, we connect to the cloud data center. And in the cloud data center, by using the various communication channels, networks, the various resources are pulled together and are made available to the user for performing his functionality like computation, storage, IO, etc. Then, why the cloud computing? What is the need of cloud computing? Why the people are much speaking about cloud computing? Why cloud computing has become a mandatory mandatory technology for computing nowadays? The answer is very simple. When we look back to the history makes us clear the problems that which we are experiencing are the problems for which we are required to bring out solutions are increasing with complexity day by day. And as they are increasing with complexity, we require a high computation power and we require huge storage for storing data. And when I'm saying about huge computation power, when I'm speaking about huge storage, all this making available in an organization premises, or all this making available to an individual user is not so easy. Now, with coming to the cloud computing provides the huge processing power and huge storage space to the end user as and when required. And this is all possible, and this is all made possible with the help of the commodity hardware. Here I am introducing the term commodity hardware. What does this commodity hardware says? As I said, cloud computing supports working for the complex engineering problems or the complex computation problems. Further, the cloud computing is not going to have a supercomputer with it, but the cloud computing is going to provide that computation power with a commodity hardware. Commodity hardware is nothing but the low-cost hardware. The desktops that which we use, the laptops that which we use, such low power nodes, low power computers are used and they are interconnected together so that all of those low cost commodity hardware, low cost hardware together helps us in working for the huge computation power. So what does this cloud computing is going to offer? As I said, let us take an example of an organization, say A. So it is having its on-premises computing facility. And one day, suddenly the organization have got a lot of new projects. And to work with the projects, they require huge computation power, huge IT infra. Now, if the organization decides to procure that IT infra, it takes a lot of time because the organization have to get the quotes from various vendors for purchasing the computers. And once the quotes gets finalized, the computers are required to be procured. They are required to be networked. The licensed softwares has to be purchased, and the whole infra has to be made ready. And this takes a lot of time, say 2 months, 3 months, 6 months, or a year of time. But an organizations have some projects in hand which has to be deployed, developed, and handed over to the customer. So now, here in this example, the organization, instead of working for the projects which it has received from the customers or the clients, it has to pay its attention in procuring the IT infra. But now, when that organization has moved on to the cloud, has migrated onto the cloud, it can get the required resources immediately. Just the way how we purchase a SIM card and start using our mobile phone, the same way an organization can request the required processing power, required storage capacity, etc. from a cloud service provider, and the required resources will be made available to the subscriber or the user in a very fraction of time, and they can actually start using the cloud infra for working with the client applications or the client projects. So in this case, the organization is not required to concentrate on networking the IT infra and concentrating on purchasing or procuring the software licenses and making the deployment platform ready. So all this is possible just in a minutes of time, and this is what exactly the benefit of using cloud computing. But alongside with the benefits, there are also a lot of disadvantages the organization started thinking about by using cloud computing. And when we look at the 21st century organizations, the important asset of any organizations is its data, than their infra, than their manpower. It is the data which they have generated from the transactions with the customer is an important asset of any organization. So when an organization migrates its IT applications onto the cloud environment, automatically the data and organization applications will reside in the cloud computing environment, which is a remote location. And organizations will always lose control on their data, which is an important asset, and is actually going to depend on the third party cloud computing infra managed by some third party. So there is some kind of trust that has to be established so that the organizations start migrating onto the cloud. Now, to understand the reality, the cloud computing technology has provided enough trust to the organizations. And now in the current day scenario, if we see, more than 80% of the organizations have migrated their applications onto the cloud and are functioning from the cloud infra itself. So the another key advantage the organizations gets is reduction in their capital investments. Say now when an organization want to maintain its IT infra on premises, they have to purchase hardware, they have to procure the licenses for the software, and definitely the cost to be invested, the amount to be invested is going to be very high. But migrating onto the cloud and just subscribing to the resources from the cloud is always going to be cheaper to an organization, and that actual money can be invested by the organization for their actual business and can increase their return on the business, and can definitely show a lot of benefits and profits to their company shareholders. So this is where the cloud computing has gained an advantage from the organizations, and they have started migrating onto the cloud. So to understand even before going with the major advantages, to understand what are the key characteristics of the cloud computing environment. In simple to say, the first foremost is on-demand self-service. So the cloud computing environment do not require much of manual intervention. It auto-tunes itself, and there is some automation which helps us in procuring the resources without having much manual intervention. So this is what we call it as on-demand self-service. As and when you say that you require more processing power as a subscriber, the cloud service provider, without any manual intervention, the software itself provides you the required processing power. As and when you do not want, again, the same thing can be done over there. The second foremost characteristic is the broad network access. As I already mentioned, please do remember the cloud computing uses distributed architecture. As I said, the cloud computing infra is made of commodity hardware, and we call it as a data center, which is nothing but a collection of the low-cost hardware, and we are able to access them by using some network. And as I already mentioned, the cloud computing supports a broad network access. If we do not have the network access, we can't access cloud computing. People say we have a supercomputing in our hand when we are having an internet connectivity connected to a cloud. And when we do not have internet connectivity, we are just deaf and dumb. This is what happens with using cloud computing. So the another key advantage is the resource pooling. As I said, the cloud computing uses the commodity hardware, low-cost hardware, and which are geographically distributed, and all those resources are pooled together, and which can be done through that broad network access, which is nothing but an intraconnect for procuring the required resources. The foremost key characteristic is rapid elasticity. Here I'm not speaking about scalability, I'm speaking about elasticity. What does scalability says? Procuring the resources as and when required. And elasticity says releasing the resources as and when we do not require. Say for example, for my organization, I require 10 gigahertz of processing power, 10 megahertz of processing power, something say. And in the next instance, I just require only 2 megahertz of processing power. Definitely it can be done. That is all possible with the rapid elasticity. And because of the rapid elasticity, we are going to pay only for the resources which we are using. So that is what actually the key advantage of using cloud computing. Please do remember, cloud computing is an utility computing model. The way how we provide the subscription charges to our mobile service providers, we are also required to pay similarly to the cloud service provider for providing all the required resources which we have procured from the cloud computing environment. And to make you understand, one article I read a few days before, and I came to know that, say from around 2010 later, AWS, Amazon Web Services, has reduced its pricing for 64 times, but it has never increased its pricing, but actually reduced the pricing. To make you further understand, if you could see the mobile service providers also, if you look back to the history, say from 2005 or 2006, when the cellular networks have come, the call cost has completely drastically come down. The subscription charges has drastically come down. So this is where the utility models are going to help us by reducing the amount invested in utilizing the very effective and quality services. That is all possible again with the cloud computing for using our cloud resources, computing resources. And the next key characteristic is measured service. As I said, we are going to pay for what exactly we used. So that is what we call it as a measured service. So the cloud technology is going to measure the usage of the infra, say processing power, say storage power, say IO, etc. and we are going to pay for only what actually we use. And this is all possible only because of rapid elasticity. And rapid elasticity is possible because of the cloud supports resource pooling. And resource pooling is possible because of having the broad network access. And all this is done with a self-service without having any manual intervention. So these are the 5 key characteristics of the cloud computing environment. So moving further, the basic challenges of using cloud computing, as already I mentioned, security and privacy. Because of moving on to the cloud, we are going to lose the ownership on the data. The next key challenge is interoperability. Say some organization want to migrate few of the resources onto the cloud and few they want to operate from their self premises. And say consider some organization want to procure some resources from one service provider and some resources from the other provider, which speaks about interoperability. Say, I want to procure some resources from Amazon and some from Microsoft and some from Google. So my application works seamlessly when there is some interoperability between these all service providers. Otherwise, as a subscriber, I'm going to experience a lot of difficulty as well. The other one is about portability. Say, I migrated my applications onto Google Cloud, and say I'm not happy with the Google Cloud uh, facilities or the features or its service, then I want to migrate onto the AWS. How does that portability support I have when I migrate onto the cloud? The next one is about computing performance. So am I going to get the required computing performance as promised by the service provider when my organization transactions are at peaks? So that is another key challenge. And another one is the reliability and availability. Say now we are migrating our application onto the cloud, and the question is the cloud servers available for you during your transactions? If they go down, how your business is going to run? And as well, the reliability is another one. You are putting all your data onto the third party, and how reliable they are and how reliable their services are, so that your business as transactions are not going to get affected. So all these are very big, broad research topics, and a lot of research is going on. A lot of solutions have already come in, but still people are trying to give the best and best from the cloud computing by overcoming the mentioned challenges. So then coming to the benefits, mostly already I covered. One is flexibility is one, like the way we do elasticity. We can procure the required resources, we can remove the resources that which we do not want. The next one is about the disaster recovery. And here to speak about cloud computing supports distributed computing architecture, and the distributed computing architectures are always not fault tolerant. But cloud computing being a distributed computing architecture, but is fault tolerant. So if you store some data, the cloud promises that your data is already always available. So even if a node gets failed where your data is stored, we are able to recover the data. And this is all possible because cloud manages 3 copies of the data. It maintains redundant copies of the data. If one copy is lost, we are able to recover the data from the other copy. And the next one is about automatic software updates. So not required to look at the expiry of the software licenses, not required to look at versioning of the new softwares, updates, patches, everything will be automatically done. And the next one is pay as you go. As I said, cloud computing is an utility model. We are going to pay for what we use, and we are not going to pay for what exactly we have not used. And the another one is about increased collaboration. If you people see the AWS, if you just open your browser, and you could see there are some 50 plus various kinds of services available from Amazon, and the services are increasing day by day. So there is a lot of collaboration. Whatever the kind of resources you require, whatever the kind of services you require, everything is available on the cloud, and it supports that increased collaboration. And not only that, we are able to integrate with other applications, and from where you can scrape the data, you can get the data, you can send the data. All this is possible. And the next one is about the document control. We can always control the data relevant to your application, the data relevant to your agreements, etc. And the next one is about security, and cloud is very good at providing the security with the role management with the access control as well as authentication, authorization, etc. And cloud is location independent. As mentioned, the data centers are geographically distributed and are present at a different location from the location where we access. So the cloud infra and the data storage is completely location independent. You may be from India and you migrate to an application onto your cloud, and your data might be residing somewhere in some, a data center present in some different country. So these are the various the cloud computing benefits. And there is a lot to speak about each and every point, but with the limited time, I'm not going to discuss much about them. And these are the few cloud computing terminologies which everyone should know when learning about cloud computing, and when trying to understand about cloud computing. The first one is the cloud service provider. I hope already I'm using this term. Cloud service provider is nothing but the individual who provides services like Amazon, like Microsoft, like Google, etc. We call them as a cloud service provider who provides the cloud computing technology. The cloud data center is nothing but a location where the cloud infra is available. And the commodity hardware, as I said, it's nothing but the low-cost hardware integrated together and which supports the functionality for the complex problems. Next one is about utility computing. As I said, people call cloud also as a utility computing because we are not going to own the cloud infra. We are just going to subscribe and we are going to use it and we are going to pay for it. And next we call it as ubiquitous computing. What does this mean? If you have a desktop or a laptop with an internet connectivity, you are able to access your application migrated or stored on a cloud from anywhere. And we call it as ubiquitous. So it is nothing but anytime, anywhere, round the clock. And from any geolocation, you are able to access your required computing resources, and we call cloud as ubiquitous computing model. And moving further to better understand about cloud computing, how this cloud technology is available for the end user. So when we look at to understand cloud computing, we should know the cloud service models and we should know the cloud deployment models. So here, if you could see, both are actually available, the service models and deployment models. Coming to the service models, we have infrastructure as a service, platform as a service, and we have software as a service. And people say cloud stack. And when you look at the stack also, people always place infrastructure as a service at the bottom, and in between, on the top of it, platform as a service comes, and the top of it, application as a service comes. So the first point is, what is this infrastructure as a service? So as I said, cloud computing is nothing but computing on internet, and computing comprises of storage, processing, I/O, etc. As I already mentioned. So whatever the services relevant to processing, whatever the services relevant to storage, or whatever the services relevant to I/O, all those are available as a separate category, and we call it as infrastructure as a service. So whenever you require some hardware resources for your computation, so we always go for procuring infrastructure as a service. And a very simple example is Amazon EC2, Amazon S3, etc. And then we have another service model, we call it as a platform as a service. What does this mean? So as a software engineer, we always develop some applications. And for developing an application, we require some deployment platform to be ready. Say, for example, if I want to develop a Java project, I require my full stack Java environment to be ready. If I want to develop a .NET application, I require my whole .NET framework with the .NET technology, with the middleware services and the backend databases should be made ready with their license procuring, etc. And with all the required plugins, with all the required version management, everything has to be made ready. And we are going to develop our application on that particular platform ready environment. And here, cloud supports that. So we are going to have a platform on which we can develop and we can deploy our applications without worrying about procuring and installing those softwares, and we call it as a platform as a service. And a very simple example is Azure is one such platform as a service which is available for us. And on the top of that, we have software as a service. A simple example is I own some software, and I want to, give this particular software to the end users for usage, like Facebook, like Gmail, etc., where people are not going to purchase the software, but by having a user ID and password, people start using it. And we call such as software as a service. And software as a service helps in running the business. So myself, I own a software, and if my software is my business, then automatically I'm going to use software as a service. And here we can see that organizations will procure one or two or all the three services based on the requirement. Say, for example, if I want to start a business and my business is nothing but a software like Paytm, PhonePe, etc., and for developing and deploying that, I require platform as a service. And for managing my customer transactions, I require infrastructure as a service. And for making my software available to the end users, I require software as a service. So this is the way how the various cloud computing services are used. But nowadays, many other services are coming in. Nowadays, people are saying storage as a service. People are saying desktop as a service. People are saying security as a service. People are saying AI as a service. Like that, this stack is increasing, and a lot of subcategories are coming in this particular services. But basically, to speak, the cloud service model speaks about infrastructure as a service, platform as a service, and software as a service. And in addition to the services, looking at the security, looking at the privacy demand for the subscriber from the subscribers, the cloud computing infra is made available in various deployment models to the end customer. And the major deployment models are public clouds, hybrid clouds, private clouds, and there is also one more model, we call it as a community cloud. What is the difference is? In simple to say, the very cheaper cloud, offering is a public cloud. Actually, public cloud supports multi-tenancy. In the sense, whatever the computing resources available will be shared by the multiple subscribers. But here, the security is not that promising. And a lot of research is happening to make public clouds more secure so that the businesses will save a lot of money. So now, there is another offering which we call it as a private cloud. The concept is very simple. When an organization wants to migrate onto the cloud but is not ready to share its application, share its computing with some other organization, and more concerned about security, they always go for a private cloud. And a private cloud do not support multi-tenancy. But the security is very high as well. The cost for subscription is very high. And then the another model has come, which we call it as a hybrid cloud, which is a combination of public cloud and private cloud. And some organizations, what do they do is, all their data do not require higher confidentiality. So in such case, they partly require private cloud and they partly require public cloud, and they go for a hybrid cloud. So what does this hybrid cloud helps? Hybrid cloud provides the same amount of security what private cloud does as well. The cost of procuring hybrid clouds is cheaper than private cloud. So taking the advantage of public cloud and a private cloud, the hybrid clouds has come. Then I am speaking about another cloud, which we call it as a community cloud. And this community cloud is nothing but just a public cloud, but it supports multi-tenancy, it is cheaper and everything, but only the organizations of the mutual trust will subscribe to that particular community cloud. So these are the various deployment models and service models through which the cloud technology is available for the end users, and all the choices are available for the subscribers or the users for opting a choice, so to better utilize the cloud services. So just to understand, already I explained what does this deployment models does, or service models does. IaaS, what does it do? It gives a simplistic view of IT, that is infra. What does platform as a service does? It gives a simplistic view of programming. What does software as a service does? It gives a simplistic view of services from the softwares. So in simple, to make you understand about the various service models. And As already I mentioned about the cloud deployment models, this particular diagram gives you some understanding about them. Private cloud is single organization, you could see. Public cloud is again a general public, multiple organizations use. Community cloud is nothing but organizations with mutual interest, shared interest which does, and all the combination is nothing but a hybrid cloud. And people can, this diagram makes you clear, and it depicts a clear understanding for you about the various deployment models. So we need to understand about the various cloud computing players as well. The landscape is very big. I'm just all this time I'm speaking about only Amazon, Microsoft, and Google, but there are lots and lots of cloud service providers available, and you could see the first topmost end user applications, nothing but software as a service. These are the various applications which are already hosted on the cloud and are available as a software as a service for the end users. So it might be an organization, it might be a user who is going to subscribe to these softwares, and without purchasing, without investing much money, they can start using those services. Then they can get the benefits from this particular softwares. And below that you can see developers and IT, the people who are from software industry, who have to develop applications for other customers, or who has to give the IT solutions. They always use platform as a service. You could see that various softwares are there, and below that you can see infrastructure as a service. They are nothing but which supports the processing power, which provides virtualization, which provides storage, etc. And all this falls under infrastructure as a service. And these are the key players, and a lot most players also might have come. And this slide is a bit old, right? And lots of players have come into this particular landscape. And further, to make a career in cloud, we also need to have an understanding about few new technologies which have come on the top of cloud, and we call it as a fog computing, we call it as edge computing, and there is a lot of confusion for the people between what is cloud, what is fog, and what is edge computing. As I already mentioned, cloud is a distributed computing model and located at a remote place, and we are going to communicate to the cloud through an internet. And look at here, for every single transaction, we are always required to run our transaction through an internet, through some network, move on to the cloud data center, get your results back. So definitely the cloud data centers or the cloud technology will increase the network traffic. And because of this network traffic, always cloud speaks about performance, but there is always some latency involved. Latency is nothing but a delay in getting the response. So later on, the researchers have come up with another technology, and people call it as a fog. But fog works like a subnet to the cloud, not individually. What is fog? Fog is nothing but, we can say, a computation facility available in a local area network. Say, for example, I'm an organization and I'm running my transactions. I'm going to have my fog computing environment available in my local LAN. And some of my transactions gets executed in my local LAN only, not exactly going to the cloud. Sometimes, whenever required for more data or more computation, then my transaction goes to the cloud. So we are going to have an intermediary cache capacity or intermediary, computation capacity, and we call it as a fog. And fog is not distributed, and fog is made available only within the LAN, that is a local area network. Then the other computing has come, people call it as edge computing. And what does this mean is, edge is nothing but at the end, from where the data gets generated. And now all this time when we speak about cloud, we say data gets generated at one place, stores at one place, processes at one place, and all this is going to happen through a network. But coming to the edge, here edge computing says the place where data is collected, the processing happens at the same place. Say now, from where do we get data? These days, if you can see, it's nothing but IoT, it's nothing but sensors from where we get data. And some minute low-level computations happens within the device itself, and we call edge computing. So now, when you look at this particular diagram, this gives you an understanding. The end user connects to edge. Some simple, computations or calculations, processing will be done within the device itself. And beyond that goes to the fog, and bit complex gets executed at the fog, which is available in the local area network in the premises. And again, beyond that will go to the cloud data center. And overall, this particular stack helps in improving the processing power and will improve the performance of the application and reduces the delay or latency to the end user. So in simple, I hope this might have given you an understanding between cloud, fog, and edge computing. And the real-time applications are basically using all these three these days. So moving further, what exactly the opportunities available? As an engineering individual, if you want to make some career, especially into the cloud, and always the most promising and uh, a very good career opportunity in cloud environment is nothing but a cloud architect. And the major responsibility lies is uh, procuring the right services, integrating the required services for the end user so that he runs his application seamlessly. This is what actually the major functionality of the cloud architect. And the next one is about the cloud support engineer. If so your application is migrated onto the cloud, and the support that you required for running your application seamlessly from the third service provider is nothing but we call it as a cloud support engineer. This is another role available. And the another role is software engineer, nothing but here developing and deploying applications on say Azure or any other platform as a service. So nowadays for software engineers, may you are a Java engineer or whether you are a .NET developer or whether you are a Python developer, people always expects you the cloud literacy, knowing how to work on a cloud platform as a service like Azure. The next one is about a cloud automation engineer, as I mentioned, an individual who helps you in integrating the cloud services with some kind of hardware or with other services. These are the major career opportunities available in the cloud, and a lot of certification courses available. And here, when learning about cloud, if you could search on internet, if you could see, sometimes people speak about AWS, some people speak about Azure, some people speak about Google Cloud, but do not get confused. Focus on some offering either AWS or Google or Azure, but learn the complete. And once you could learn one cloud completely, understanding other or working on the other is not going to take much time. So it's not awareness on all the clouds are required, but an expertization in one cloud is very much going to help you. And for the participants from Vardhaman, I hope they have a very added advantage that Google have started offering the Google Cloud Readiness Program, and I hope I could see around 240 people are already experiencing using the cloud infra. And this literacy is really going to help you even if you become a software engineer on any of development technologies as well. That is really going to help you in understanding what exactly is required for a cloud architect. So these are the various career opportunities you people can think of to start your career in cloud. And other than the Vardhaman people, even you people can connect to this organizers like Akash and Prashant, because even other college students also can enroll and can take those Google program, but from Vardhaman. But still, there are many other resources available for free from where people can learn. One is AWS Educate. Vardhaman is a member of AWS Educate. Like that, you can ask your college or the department to enroll for AWS Educate. This is an offering from Amazon Web Services, from which the students, educators can access AWS technology like EC2 or Amazon S3, etc. at free of cost, and can start exploring and understanding how the services are available, can deploy as well. These are the resources which are available for free of cost. Similarly, Azure is also available. You can see this particular slide. Microsoft Azure is made available for the students that $100 credit, $100 of cloud services are available for a student. And by using which the virtual channels can be developed, applications can be deployed, and can explore how the platform of service is available, can have some SDKs available. And while using these services as a student, I always try to use freewares like Linux as OS, use Android SDKs, which are again free of cost, so that you can explore the cloud for a longer time. If you take Windows as your OS, $100 will be exhausted quickly. Like this, even if you have some innovation problem, you can always approach Azure, and for your innovation, Microsoft provides the cloud services at free of cost. If really you are developing a very good innovative project, the computing resources are available at free of cost as a corporate social responsibility from all the cloud service providers. So similarly, even Salesforce does. Similarly, as I said, Google does, and a lot of services are available for us for accessing the cloud environment.